Hi, we're here in the Robonaut 2 lab today at the Johnson Space Center talking with Lyndon Bridgewater, who is the Chief Mechanical Engineer for the Robonaut 2 project and also for a new project that he's actually wearing on his hand. Can you tell us what this is, Lyndon?
This is the grasp assist device that we're using for developing technologies for assisting astronauts on suited gloves or assembly line workers down here on Earth so that they can handle repetitive tasks and heavy lift tasks.
Okay, grasp assist device. It's a robot on your hand, right?
Exactly, it is a robot on your hand. It is basically assisting me or its operator in order to carry an object or grasp an object.
Why would we need that?
So from NASA's perspective, spacesuits are like a pressure bubble that astronauts are trying to squeeze down and pull on every time they're doing an EVA. In order to help take that burden away, we've put mechanical actuation systems on board with computers and sensors that allow an operator to trigger the device and make it close the hand down instead of the astronaut having to fight it himself.
Close it open a few times so they can hear that. Hopefully y'all can hear that whirring going on. What is that? What's doing that?
Those are several actuators that are located back here in the forearm of the glove. They are triggered by a sensor within the glove that tells it when to open and close. And all of that's processed by computers that are on board.
And you've got it attached to a battery here on your back.
Correct.
Okay, so it basically makes your grip stronger.
It does. It either makes me stronger or it allows me to hold an object that I can normally hold longer and with less effort. And
we hear that spacewalks are really hard on your hands because the gloves are hard to use and you just use your hands a lot in spacewalks.
That is absolutely correct. An astronaut, in order to move around, they're not moving around by walking, they're having to climb. So everywhere they're moving, they're using their hands the entire time. So astronauts before an EVA are working their hands out a lot. You see them around campus walking around squeezing tennis balls all the time. This is something that we're working on in order to try and take away some of that brutal effort that comes with the EVA walks.
It doesn't make you superhuman, right?
It doesn't make you superhuman. We're only adding about 5 to 10 pounds worth of extra force in this design right here. We can change that to be a little higher, a little less. We can change the way that it closes down. So if you're trying to hold a drill, grab down on the grip fingers and then allows the trigger to still be actuated. So we can do quite a lot of things with this.
Very interesting. And how is this related to Robonaut?
So this is a direct offshoot of some of the technology that we were developing for Robonaut. One of the nice things about what we were doing is a lot of the stuff for Robonaut was inspired based on human anatomy because we were developing a robotic hand just like ours. And through that development, we realized that not only can we use the same technology to make a robot move, but we can put that same technology onto a human to make our movements easier.
So when we were talking earlier, you said basically the human hand inspired the robot hand, and now that design on the robot hand is helping human hand again.
Exactly.
Very nice. So spacewalks are what we're thinking, but there are other uses, right?
Correct.
It could be for here on the ground.
Correct. More terrestrial applications. We're looking at General Motors' direct application for assembly line workers. They have to carry relatively heavy objects. Their tools can be relatively heavy. Some of the grasp that they're required can be relatively burdensome on the assembly line workers. So this is to take off a lot of that so that they can do repetitive tasks for longer without any inherent injury to their arms.
Okay, and I think we're going to talk with somebody from GM next. So real quick, if I shake your hand, will it crush me?
No, it won't. It's nice and safe.
Very nice. Thanks.